important part in any Maths IA or Paper 3 question is to then be able to extrapolate your knowledge. So we've worked out what the pattern is for 3 symbols, and now we're going to go back to our Harry Potter deck and apply that knowledge to a card that has 8 symbols for every 1 card. So the first question asks us, how many combinations of distinct symbols can be made from this card? Well, in this case, it's simply 8, choose 2. In the same way here, we could have generalized this as 3, choose 2. We've got 3 symbols to choose from, and we're selecting 2 for each pair. In this case, we do not use permutations because the difference between permutations and combinations is that in combinations, order is not important. In permutations, think permutations pin, like your bank pin, it is important. And in our case, it doesn't matter which way around we select the pair. And that's 28. Okay, so we can create a universal set of S symbols. Now these capital S symbols are going to be the symbols that we're going to use throughout the entire pack. Okay, so we've seen a selection of the symbols here, but if I add more cards, for example, here we've got Dumbledore, we've got Hermione, we've got Snape, the Chocolate Frog, the Weeping Willow. The S symbols are the total set of symbols that are used on every card throughout the deck. Okay, so for each card in the deck, we will select S symbols for each card in the universal set. How many combinations of distinct pairs of symbols can be made from the universal set? So this is saying about the total number of symbols I have to choose from is capital S. And then for each pair, which could appear on any card in the deck, I'm going to have total number of symbols, choose 2. And I'm going to simplify that as S times by S minus 1 all the way down, because that's a factorial, divided by 2 factorial, divided by S minus 2 factorial. Well, there's a really neat trick for simplifying combinations, which is if I open this up, my larger factorial, my S factorial, in fact, I'll start by writing that slightly as S factorial. If I open up my larger factorial as far as my smaller factorial, so S minus 1 up to S minus 2 factorial, okay? I can cancel these down, and that will leave me with the expression big S times S minus 1 over 2 factorial, which is just 2. So the total number of pairs throughout the entire deck, if I looked at every single card and wrote down all of the pairs and kept a record, would be the total number of symbols times by the total number of symbols minus 1 divided by 2. That's the end of the next series of maths where we looked at distinct pairs, and this is really important in creating the generalization that we're going to be after. In the next section, we're going to be looking at how you can include mathematical representation in your Maths IA, and we're going to be introducing a Levi graph, which is something cool that I hadn't seen before. I'll see you in the next video, guys.